Calculating the viscosity of a gas mixture. A natural gas mixture consists of three components: methane, ethane, and propane. Their mole fractions and viscosities at a particular temperatures are indicated below. Now we are asked to calculate the viscosity of the gas mixture. So what we're going to do, the way to do that is that we're going to form a table. Now we have component table, which is C1, C2, C3. Now we have the mole fraction to be Y, and the mole fraction for C1 is 0.90. The mole fraction for C2 is 0.08. The mole fraction for C3 is 0.02. Now let's input the molecular weight. So the molecular weight for methane is 16.04. The molecular weight for ethane is 30.007. For propane is 44.10. Now the square root of the molecular weight. Now let's look at the square root of molecular weight of methane. You have 16 point, the square root of 16.04. That will give us 4.00. The square root of 30.07. That will give us what? 5.48. The square root of 44.10 will give us 6.64 in two decimal place. So now we now have the value for the viscosity is what they gave us. Viscosity for methane is 0.013. The value for the viscosity for ethane is 0.0112. For propane is 0.0098. Now, to find the viscosity of a gas mixture, the formula for viscosity of a gas mixture, let me just say viscosity of a gas mixture will be the summation of of the mole fraction times the square root of the molecular weight times the viscosity divided by the summation of the mole fraction times the molecular weight of each, just like this one is each component. The summation of the mole fraction of each component times the square root of the molecular weight of each component times the viscosity of each component divided by the summation of the mole fraction, that is the product of the mole fraction, times the molecular weight of each component. So invariably this can be written as the move the viscosity of each component, the summation of the product of each component times the mole fraction times the square root of the molecular weight of each component divided by the summation of the mole fraction times the square root of the molecular weight of each component. So this is the formula. So now we are going to now be able to now look at this critically. We're now going to multiply this, and this to get this whole thing. So we're going to get, first we're going to multiply this and this to get this one down here, which is y, the mole fraction component times the square root of the mole fraction. So now we're going to multiply that. So now what we're going to get is, we are going to see now 0.9 times 4 will give us what? Here will give us 3.6. Now 0.08 times 5.48 will give us what? This will give us 0.44384. Now if I now say 0.02 times 6.64, I will have here to be 0.1328. So now the summation of mole fraction times the square root of molecular weight of each component will now be equal to, now we just to add all this together. I'll add them together, 0.1328 plus 0.4384 plus 3.6. So this will give us what? This gives us 4.1712. Now let's now go to this other side. We now have to calculate. We now have to multiply this one with this to get the whole of this. So now we now have viscosity times y, that is viscosity times mole fraction times the square root each component will now give you this times x. So it's this times x we're going to do now. So now, so 0.013 times 3.6. So here will give us what? 0.0468. Now 0.0112 times 0.4384. This will give us 0.0049. Now 0.0098 times 0.1328. This will give us 0.0013. So the summation of the viscosity times the mole fraction times the molecular weight, the square root of this molecular weight will give equal to what? So now let's add all this together. We now have 0.0468 plus 0.0049 plus 0.0013. So we have 0.05353. So now using this formula here, now we have this as 0.053 divided by this value here, which is 4.1712. So the viscosity of the gas mixture will not be equal to 0.053 divided by 4.1712. So to give us 0.0127. So that is the answer. Thank you for watching till the end. Have a nice day. Please do well to watch my channel and also